In this video, we're talking about corresponding parts of congruent triangles. So how do we write these proofs for maybe how triangles are congruent, like the first example, without some of the given information, some of the information we have to pull from what we already know. But our main goal today will be to get to writing proofs where we're not necessarily proving that the triangles are congruent, but we're proving some part of the triangle is congruent, so that if we can find two triangles that are congruent, we can get to the parts that we want. So just looking at this one, and for this one we're just going to do a statement reason proof. I'm pretty confident that you guys can write sentences from a statement reason proof on your own. So for this one, we're just going to write the statement reason proof together. So if I start with my chart, I can start with what's given, and on this one it's a little different how they give you the information. They're giving you the information by marking the figure. So we can say that VW is congruent to YW. That's given. And we can also say that ZW is congruent to XW. That's also given. We also know something else about these triangles. Based on the way the figure is drawn, we know that this angle is congruent to this angle because it's a vertical, because they're both vertical angles. So we can add that to our statement reason proof. We can say angle VWZ is congruent to angle, and we have to go the same way. If we start with V and go to W and then go to Z, then we have to start with Y to W and then W to X. So we would say angle YWX is congruent. And the reason, how do we know that? It's because they're a vertical pair. Then looking at that figure in the congruence marks, I can go ahead and prove that VWZ is congruent to triangle YWX. And we're going to use our side angle side congruence conjecture, because that's exactly what I have. Side angle side, side angle side. It matches up. So I know that those two triangles are congruent by side angle side. This next example is a little bit different. They give us the given information kind of written out, and they're asking us to prove that triangle BDM is congruent to triangle CFM. So like I said, the first thing we want to do is we want to take our given information, we want to mark up the picture so we can kind of see what congruence shortcut is we're looking at. So if I mark up angle B is congruent to angle C, angle D is congruent to angle F, and M is the midpoint of, that should say BC. So if M is the midpoint of BC, what do I know about a midpoint? I know that that's going to split the segment into two congruent pieces. So that means that's going to be congruent to that. So when I look at those two triangles, I'm really looking at a angle side relationship. So I've got angle side, angle side. So once again, I'm going to just write the statement reason proof. And I'm going to start with what's given. So angle B is congruent to angle C, given, and angle D is congruent to angle F, that's also given. And M is the midpoint of BC. And I look at my givens and I say, okay, is there anything from those givens that I can tell, or is there anything in the picture that I can tell? And we already talked about that. M is a midpoint of BC tells me something. It tells me that BM is congruent to CM. And how do I know that? I know that because that's definition, and we'll just abbreviate that DEF period, of a midpoint. So then I can say, okay, based on all of that information, what do I know? Well, that tells me that triangle BDM is congruent to triangle CFM. And again, I'm going to use my angle side congruence conjecture. My next step would be to take this outline that I have in my statement, reason, proof, and to go ahead and write sentences. So I might say something like, we know that angle B is congruent to angle C, and angle D is congruent to angle F, period. We also know that M is the midpoint of BC, which means BM is congruent to CM by the definition of midpoint. We can conclude triangle BDM is congruent to triangle CFM by angle side congruence. That would be one way that I could write up that paragraph, and we've talked about this a lot. There's lots of different ways you could write up that those sentences, but you can see your statement reason gives you the outline for what you're going to write in those sentences. So example 3, we're given that HI is parallel to LK, so I'm going to mark up my figure. Remember, those arrows mean that it's parallel. And I also know that IK is parallel to HL. And this time I'm not proving that two triangles are congruent. I'm proving instead that angle LHI is congruent to angle IKL. Now, the way that we get to the prove part is that we first pick out two triangles that we can say are congruent. And we're going to get to use some of our parallel line properties here. So if I look at HI parallel to LK, this right here would be my transversal. So I know a couple of angles that are congruent based on those two parallel lines. I know this one right here is congruent to this one right here, and I know that because they're alternate interior angles. When I look at this parallel line with this parallel line in the same transversal, then I know that this angle is congruent to this angle by the same reason. They're also alternate interior angles. Then something really cool here happens. I'm starting to see that I have a triangle right here, and I have a triangle right here in HLI and KIL. And what I notice is that they share this side right here. They share that. Well, shared sides are always going to be congruent because it's congruent to itself. So I can look and I can say, oh, okay, I see two triangles kind of popping out there, and I can see my congruent shortcut is angle side angle. So if I write this up in my statement reason, I start with my givens. HI is parallel to LK, given, and IK is parallel to HL, also given. Those two sets of parallel lines give me that angle HIL is congruent to angle, and I want to stay consistent. So I'm going to go KLI. And the reason, how do I know that? How do I know those are congruent? That would be because they're alternate interior angles conjecture. Okay. I also know that angle HLI is congruent to angle KIL by the same reason. They are also alternate interior angles. And then we said, okay, we've got this same side here, the shared side, so I know that IL is congruent. And so IL for one triangle would actually be LI for another. So remember, I have to line up those parts. So IL is congruent to IL, and how do we know? Well, that's the same, it's a shared side, so we can just say shared side. It's also our reflexive property. We talked about that a little bit in when you were just learning basic properties. The reflection of something, same thing, right? I'm looking at the reflection of it. So now I can say my two triangles, triangle HIL is congruent to triangle. So I went HIL, so I need to go KLI. And how do I know that? I know that because of angle-side angle congruence. Okay, those two triangles being congruent tells me that all of the parts match up. So now I can say that angle L, HI, is congruent to angle IKL. And the reason, how do I know that? Well, I know that because these two angles are corresponding parts of congruent triangles. And we abbreviate that in our statement, reason, proof. When you write it out in your paragraph, yes, you're going to actually write those words out. But in your statement, reason, proof, we just say corresponding parts of congruent triangles are congruent. Okay? And there's your proof. And again, after this, you would write up the paragraph that goes along with that. And there's many different ways to write that paragraph. Our last example that we're going to look at today is this one. It says side MS is parallel to segment TR, and segment MS is congruent to segment TR. And they're asking you to prove that A is the midpoint of MT. So if I mark up the figure, I know that MS is parallel to TR. I also know it's congruent to TR. Those parallel markings are very important because those parallel markings tell me something. If I look at these parallel lines with this transversal, then I know this angle right here, and I'll do that in red so you can see it a little better. This angle would be congruent to this angle because they're alternate interior angles. I also know by looking at this transversal that this angle is congruent to this angle. Same reason, they're alternate interior angles. And then with side MS being congruent to side TR, that tells me that those two triangles that I see there are congruent by angle side angle again. So I'm going to start my statement reason with building that those two triangles are congruent. And I'm going to start with my given statements. And then from this first given statement, I have that angle S is congruent to angle R by alternate interior angles. And I also know that angle M is congruent to angle T by the same reason. Then I can say that the two triangles are congruent. So triangle MSA is congruent to triangle, and again, I have to stay consistent in my order. So I started with the blue angle M, so I'm going to start with the blue angle up here, that'd be T, then RA. And the reason for that is angle side angle congruence. then I can say, okay, well that means that segment MA is congruent to segment TA. And the reason for that is because these segments are parts of congruent triangles. So corresponding parts of congruent triangles, congruent. And then when I know that, when I've just shown that this is congruent to that, then I can go ahead and say that A is the midpoint. Of MT. And how do I know that? Well, I know that because that's the definition of a midpoint. So I would say definition of midpoint. And there we go, that's your proof. So then you would just write it up in a paragraph. So you would just say, we know that MS is parallel to TR and that MS is congruent to TR. Based on that, we can tell that angle S is congruent to angle R and angle M is congruent to angle T by alternate interior angles. Therefore, we know triangle MSA is congruent to triangle TRA by our angle side angle congruence. This tells us that segment MA is congruent to segment TA because they are corresponding parts of congruent triangles. And then we know that A is the midpoint of MT by the definition of midpoint. So you've just basically, you have the outline for that proof right there. So in your assignment, remember, find two triangles that you can prove are congruent first, and then what does that tell you about the figure? If I know those two triangles are congruent, all of the parts are congruent. And so I can prove different things about based on those two triangles being congruent.